Hi, Denver Startup Week. I'm Ben Data, CEO of Food Maven and co-chair of Denver Startup Week, the largest free entrepreneurial event in the world, and it's only possible thanks to the support of our sponsors. We have nearly 40 sponsor companies who contribute to make DSW possible. Let's show our love for these companies today and all week long. Thanks to our title sponsors, Downtown Denver Partnership, JP Morgan Chase, Prologis, and Xero. Our track sponsors who have made all the great content you're hearing today possible: Battery 621 in the Public Works, Capital One Cafe, Colorado Lending Source, Friday Health, Quizlet, Exactly, Zayo, and Zestful. Our headline event sponsors are bringing you inspiration from around the country. Thank you to Wix, Kenzen, MAPR Agency, Obsidian HR, Kickstart Fund, Promontory Mortgage, Molson Coors, and Comcast. Finally, thank you to our partner and member sponsors listed on the screen. Thank you for your support of Denver Startup Week. Now let's get to it.
Quizlet is a global learning platform that provides engaging study tools to help people practice and master whatever they're learning. Every month, over 50 million people use Quizlet to study any subject imaginable, for school, work, or as part of their personal interests.
Quizlet is super efficient, and I often, walk to class with it on my phone or even just before I go to sleep.
Combining cognitive science and machine learning, Quizlet guides students through adaptive study activities to confidently reach their learning goals. Quizlet has over 200 employees across 3 offices in San Francisco, Denver, and London.
Being at the Denver Quizlet office for the last year has been pretty incredible. Seeing the office grow while maintaining its, core connections to our values. It's been an incredible experience to be a part of, seeing how humble, candid, and open everyone has been, and being part of a mission-driven company in a time of uncertainty has been incredibly rewarding. So I look forward to, what the future brings, because the last year has been a wonderful experience. Thank you, Quizlet.
Hey everyone, my name's Adam Bauman and I'm part of the Quizlet team here in Denver. I'm proud to work for a company that's goal is to help every single person on this earth become a better lifelong learner. One of my favorite things about working at Quizlet is how much we follow our company values. There's always learning opportunities. We encourage everybody to teach themselves something new, as well as help each other learn. Whether it's from art classes or lunch and learn talks on latest technologies, there's always something new to find and help yourself grow. And I really feel like that's one of the best things that any company can offer is growth and opportunity.
Hello, everyone, and welcome to Denver Startup Week, Day 4. I am Connor Swanson, Developer Track Chair and member of the Denver Startup Week Organizing Committee. Thank you for joining us for our first ever virtual Denver Startup Week. If 2020 has taught us anything, it's that we are more powerful when we come together as a community to share ideas and help make each other better. And here we are, virtually, showing the world what Denver is made of. At Denver Startup Week, we strive to make all of our sessions a space where attendees can connect, learn, and grow, regardless of gender identity, gender expression, race, ability, sexual orientation, and the combination of those identities. There is something for everyone at DSW. Thank you for joining us. With that said, I'm very excited for this upcoming Flutter session. I'm going to kick it off to the team to get things going. Thanks so much for being involved, everyone.
Thank you. Let me get my screen shared here and we will kick it off. Okay, so thanks everyone for taking the time to come learn about Flutter today. As the title suggests, I'll be talking through how Flutter can be used to kill 3 birds with 1 stone. You can write one code base and deploy it to multiple platforms. First, a little bit about me. My name is Rona Kilmer, and I am the co-founder and CPO of Reddiyo. I'm also the co-organizer of the Flutter Denver meetup, And I invite all of you to continue the Flutter conversation with us over there. We meet once a month, and you can find us on Meetup pretty easily and become a member and come hang out. Also, I will be sharing out the slides from the talk and the code that I'll be running through after the talk on Twitter. So give me a follow at RK Unboxed or just watch my feed there and you will find all the links. Otherwise, you'll spend the whole time trying to take notes and that's no fun. I think this is also being recorded on YouTube, so you can always go back and reference anything I talk about. So here's a quick rundown of how the next hour is going to go. I'll start by explaining why we chose Flutter for the Reddiyo app. Then I'll give a brief introduction to what Flutter is for those who are just now hearing about it. I'll touch briefly on Dart, the language that is used to write Flutter apps. And I'll do a quick run through of a demo app I built for this talk and highlight how I did a few things like simple state management and responsiveness to screen sizes. And then I'll leave you with some tools and resources to get you started. You should feel like at the end of this talk that you know enough to be dangerous and feel comfortable going out and playing with Flutter. There should be some time at the end for some Q&A. If you've got questions, you can drop them in the chat, whether you're watching on YouTube or Zoom. Specifically on YouTube, to make it a little bit easier to find the questions, go ahead and throw a prefix of #Q on there, and that'll help if there's other chatter going on in there. And then Zoom people, there should be a separate Q&A section in Zoom. So a little bit about Reddiyo before we dig in. Reddiyo is a Denver startup, and our mission is to take the complexity out of endurance training. So what does that mean? Many devices and apps are great at providing training data to athletes, but understanding what to do with that data is key. And there's a big hole in that part of the market. Our goal is to make understanding your training data easier. Today, our app builds custom dynamic training plans for cyclists, but we do have a vision for adding in running and triathlon as well. So the way it works is we review each athlete's training data and suggest training modifications based on it. And our mobile app is critical for providing this information to our athletes. And of course, we built the app with Flutter. We had a couple of things to consider when choosing an approach to building our app. Reddiyo is a small bootstrap startup, so there's no budget to hire 2 teams to build both an iOS app and an Android app. So we needed to find a cross-platform solution. We didn't go into this with a ton of mobile app experience, but spent many years developing web applications. So we wanted to find a solution that would help us make the switch easily. We had timeline constraints, of course. We needed to start delivering value with our mobile app as soon as possible. So we needed a fast development cycle. Flutter ticked all of the boxes for us. We could build and maintain one code base with Dart, a language that felt very familiar to us, and we could do it quickly. Ultimately, Flutter saved us time and money and allowed us to build a great app with a framework it's just a joy to work with. And hopefully you'll see what I'm talking about as we move through the presentation today. So what exactly is this thing called Flutter? Flutter is a UI toolkit. It is built by Google for cross-platform development. It's a challenge frameworks like Xamarin and React Native are also trying to solve. The idea is to write code once and run it anywhere. Flutter may seem new to a lot of people, but it's actually been around for a while. It's been out in production for almost 2 years now for mobile. Google is heavily invested in it. They use it for many products, and they have spent a lot of time building a community for it. Flutter is open source, so it's free to use. Like Flutter apps, Flutter itself is written in Dart. Flutter itself, the platform itself is written in Dart. So the source is readable to anybody who's working with it. It has over 100,000 stars on GitHub and a very active community of almost 700 contributors at this point. Flutter compiles to native code. That means it compiles to native binaries on mobile, and there's no JavaScript bridge. And on the web, that means it compiles to HTML, CSS, and JavaScript. Flutter is declarative. This means that you describe a new UI state to Flutter, and Flutter handles the transition. So we declare our intent to the framework. So an analogy I like is around pizza. You tell Flutter you want a large pizza with mushrooms and onions. You don't tell Flutter how to chop the veggies or make the sauce or what temperature the oven needs to be on. The interface represents the state of the app, and we'll see how this works in a bit. Flutter is not opinionated, so use whatever design pattern works best for you and your organization. If MVC is your jam, have at it. If MVVM is more up your alley, go for it. Flutter really doesn't care. You can set it up however you want. We're going to focus on Flutter for mobile and web today, but you can also build Flutter apps to run natively on desktop. Flutter for desktop is ready to go with Chrome OS. Mac OS and Linux are in alpha release right now. Windows support is still under development, but they're picking up speed over there. You can even build Flutter apps for Raspberry Pi and the mysterious new operating system Fuchsia. So eventually you'll be able to have one code base that can compile to native apps on 8 or more platforms. It's pretty ambitious, but Google's getting it done, so it's exciting. So here's some high-level architecture. Flutter is a multi-layer system, and it's this layering that allows Flutter to be deployed on so many platforms natively. Your code calls into the Flutter framework. The core framework includes all of the out-of-the-box features. You get theming and rendering, animation, gestures, all that good stuff. And the framework sits on top of a Flutter engine that's specific to the platform that you select at compile time. On mobile, the engine is written primarily in C++. It handles the Skia graphics library, the Dart runtime, and the Dart UI. And this engine compiles our app into ARM or x64 machine code. This sits on top of a runner that starts up the Flutter process. And then, of course, we have the hardware, in this case, our phones. For the web, there's a Flutter web engine that compiles the UI to HTML and CSS. And it'll use Canvas. If it doesn't get the fidelity it wants from the HTML and CSS, it'll use Canvas. Then it uses a Dart to JS compiler to convert the rest of the logic to JavaScript. And then you've got your HTML, your CSS, and your JavaScript, and it runs in the browser, which sits on your hardware. The beauty of this system is that you only have to care about your code. It calls the framework. That's it. That's all you have to worry about, these two things. Everything else is magic under the hood, and it's fabulous. When you're ready to release, you simply kick it off with a Flutter build command in the CLI. You tell it what platform you're building for, and it handles it for you. From there, you can take the Android app bundle or APK and upload it to the Play Store, or you can take the iOS IPA file and send that to the Apple Store, or you can take your HTML, CSS, and JavaScript files and ship those up to your web host, or go ahead and do all three if you want. The beauty of Flutter is you only have to write the code once and then ship it wherever it makes sense. Like I mentioned before, Dart is the language that Flutter and Flutter apps are written in. It was also created by Google, but it was created a while ago. It has been around since 2007 and is really quite mature at this point. It was designed and optimized for UI programming. Google was trying to create what they've termed UI as code. The big gain with that approach is that there's no context switching between layout and functionality. Because Dart has been around for quite a while, it has developed a rich core library. It's fast at 60 frames per second, and it's a multi-platform language. You can run it on the server if you want to. Dart is familiar. It was designed to be familiar to those working in JavaScript or Java, and it's in the same ballpark as Kotlin and Swift. So for this reason, it's a great language for teams with various development experience. Dart is object-oriented with the usual classes, interfaces, encapsulation, privacy. It also supports a functional style though. So things like anonymous functions and lambdas are supported. Dart has garbage collection, as you might expect, and it's a compiled language. It's not interpreted like JavaScript, so runtime errors are harder to come by. Dart's built with a static type system, so you get the benefits of type error checking to speed up development. It does support type inference, though, so your code can be less verbose if you prefer. It also supports generic types and classes. Dart is productive. It has great tooling to speed up development. It has first-class support in VS Code, Android Studio, and IntelliJ. And as mentioned earlier, the type checking and inference can really speed things up. But my favorite is stateful hot reload. You can see your changes with state preserved almost immediately. And I'll show you this in action a bit later when we get to the code. As soon as you dip a toe into Flutter, you will start hearing how everything is a widget. Widgets are the UI building blocks of Flutter. Everything you see on screen is a widget. You'll define other types of classes for handling business logic, but the classes you define for the UI are all widgets. Widgets are immutable, so they don't ever change. They get thrown away and rebuilt when new state gets passed in. And the framework handles all of this for you. This goes back to Flutter being declarative. Flutter gives you a ton of pre-built widgets. And I'm going to show you a few. They have a widget catalog that I will show you and walk you through just a couple of these. So they have them grouped here nicely so you can poke around. They have accessibility widgets. They have input widgets for things like forms. They have material widgets. This is a collection of widgets that use material design standards. So this, if you've worked with material before, then these widgets probably look familiar to you. Buttons, tab bars, menus, inputs, date pickers, all kinds of stuff here, sliders, so much stuff that you get out of the box with Flutter. And then another one I want to highlight is the collection of widgets called Cupertino. These are designed with the iOS style in mind. So if you've got an iPhone, these probably look pretty familiar to you. Dialogues, navigation bars, the picker, more sliders, all kinds of stuff. Flutter makes it really easy to build an app that looks like a native Android app. It makes it really easy to build an app that looks like a native iOS app, or you can use all the various settings with these widgets and build a totally branded app that looks exactly the same on Android and iOS. The sky is the limit. Okay, so let's get to some code and see how we can use these widgets. I'm pulling up a really great tool called Dartpad. You can use Dartpad to play around with Flutter without even installing it on your computer. I've loaded in this counter app from the sample pull down. Whoops, here we go. Lots of options here, but I've loaded up this counter app specifically because it is the app that you get when you first install Flutter on your system. And like I said, you don't have to install anything on your system to use Dartpad, but when you commit to Flutter and you do get set up locally, this counter app is what you will see after you do the Flutter create command in your CLI. You'll see this app referenced all over the place. So I want to give you a quick run through. As far as Dartpad goes, real quick, on the left, we have our Dart code for the Flutter app. And on the right, this is the UI, in case that's not clear. This code is generating this UI. So every app starts with the main function you see here. It loads up your main app widget via run app. So you can see my app is getting passed in. My app is our app widget. Everything's a widget. So we start with this my app widget. This is the first thing you'll ever define. This one extends stateless widget, and you'll use stateless and stateful widgets a lot in your Flutter development. But under the cover, they both extend the abstract class widget. So we have our my app widget, which is stateless and includes nothing but an overridden build method. This method is what Flutter calls to actually build the widget's UI, so it's critical. The build method must return another widget. You can see we're already declaring here that it's going to return a widget. And let's see. Sorry. Okay. The build method here is returning a material app widget. That's a pre-built widget. It's a wrapper that sets up some things like material theming. You can see it has a home parameter where my homepage widget is being brought in. Within the My Homepage app, I'm going to skip some of this stuff and get to its build app so I can show you some layout. We'll come back to it though, the rest of it. So we've got our build method. We have a scaffold widget here that's getting returned for the homepage. This is a wrapper widget. It's a material widget that aids in placing common items like menu buttons and app bars. You can see it has an app bar declared here. This is another widget. The app bar has a title, which is a text widget. The title outputs a string that says Flutter Counter App, and that is what you are seeing here on the right. Further down, the scaffold has a body. In this case, it's returning a center widget, which does exactly what you think it does. It is taking its children and centering them on the screen. Within center, you'll see there's a column widget. There's a lot of nesting going on, and we'll see why that's important in a minute. The center widget has a child of column, and a column takes a list of widgets and outputs them in a column. Shocker. Its counterpart is row, which takes a list of widgets and displays them horizontally. So there's just a few. There are hundreds of pre-built widgets, all with settings to customize them. This really doesn't scratch the surface at all. So now I want to talk about the stateful widget. I kind of breezed over that really quickly. My homepage is a stateful widget. State is the data you need in order to rebuild your UI at any moment in time. And Flutter gives you this stateful widget to use to make this easier. And you use this widget when you need to handle state specific to that widget only. It does not need to be shared. Stateful widgets are constructed a little bit differently from stateless widgets. There are two classes needed for a stateful widget. The actual stateful widget class, which is right here, and the state for that stateful widget. So that's this class here. Let's see. The state gets returned in the create state method that you must override in the stateful widget. Don't get too caught up in all of this. This is all boilerplate that whichever IDE you're using has shortcuts to spit this stuff out for you. There really isn't too much you need to know about it other than state is where you're actually going to be handling state and where the build method goes. And the stateful widget just has to have a state associated with it. So don't really need to think about too much more than that. So let's talk about what this is doing. The only state being managed in this widget is the counter's value. So this gets updated when this button gets tapped. So this is state that we have to handle. And that value is the counter value here. We trigger the state update and rebuild using set state, what you see here. Set state is a signal to Flutter that this widget's state has changed, and it calls the build method with the new state, and the UI is updated to show the new counter value. So in this case, we've got our button down here. This is the floating action button. This is another pre-built widget. We've passed in the increment counter method up here, increment counter. So when the button is pressed, on pressed, hit increment counter, and then call set state, increment the counter. So the button's pressed, function's called, the counter is incremented, the UI is updated. So pretty simple. Now, obviously, state management can get more complicated when you need to share state across different widgets. And I'm going to get to that with a demo app that's a little more robust than this super simple one. So hold on for that. A couple other things I want to point out before we jump. What about building your own widget? So we're just looking at you know, what you get out of the box when you first create your first Flutter app. So I'm just going to create a custom, I already did, I created a custom widget here. All I did was create a class. I named it Hello World, and I'm extending stateless widget, and I'm overriding a build method, and I'm returning a widget. Super simple, the most basic widget I could possibly write, I think. I'm returning a text widget, and all you have to do with the text widget is pass in a string, and it will output that string. There's all kinds of stuff you can do around styling and all of that. I'm not going to get into that, but this is as basic as it gets. So we've got this widget, but I'm not showing it anywhere. So let's throw it into the UI. Let's see, we've got a column of widgets. We've got these 2 text widgets here outputting in the column. Let's throw it here. And all I'm going to do is reference it like this. And I'm going to, I can't get to it because of Zoom isn't that convenient. 1 second. There we go. Okay, I'm going to run the app. And now we should see the text Hello World output. Cool. So this isn't a particularly useful widget, but it is a custom widget. So what about when you want to pass some data to a widget so that you can use it in the widget? That is no problem. We need to define a property, a final property in the widget. As this creates a dependency. It needs to be final, meaning it can't be reassigned because widgets are immutable. So let's see, I'm going to pass in a string and I'm going to call it location. And then I just need to pass the data through the widgets constructor. So I'm going to create this real quick. We just reference it with the this keyword. And now I've just made this property required. And you can tell that because it's yelling at me that I've referenced now the Hello World widget up here, and I am missing a positional argument. So I need to pass it a string now. And I'm just going to say, Denver. Hello, Denver. I'm going to use string interpolation to use this location that I just provided. As soon as you provide it in this way, you can use it in your build function method, excuse me. So cool, now I've passed in Denver. Let's see, it should say hello Denver when I update. Hello Denver. Okay, great. Now what if you want to pass in something, you want to give it a named parameter? You can do that, just wrap this sucker in curly braces, and now it's gonna yell at me because I've provided a positional argument instead of a named one. I just need to do this, and now it's happy again. Now the problem with the named is that if you want to make this required, you just need to annotate that. So now if I don't include it, it will yell at me. So there we go. Okay. So that's the super basic Flutter app. Now I'm going to show you the sample app that I created for this talk. So this app is a small app. I called it a Vacation Dream Book because I've been dreaming about vacations lately. I blame it on the lockdown. I started this app to collect pictures of the places I want to go. You can see it running here in Chrome. You can see it running here in my iOS simulator. I could also pull this up in an Android emulator. I don't quite have the confidence that my little system can handle Zoom, Android emulator, iOS simulator all at the same time. So just trust me that it will run in Android as well. So this app is integrated with a photo service called Unsplash. And I have it showing a default list of images from this service. You can search and favorite the different images you like. So I've just got this little favorite button that you can favorite on and off. You can search for images, different places. So I'm using something Oh, I should say this is not fully implemented. I don't have the favoriting being stored anywhere or anything like that. But it does give you, but if you go fork this repo, you'll see a lot of little examples of things that to get you started on stuff, but this is certainly not a fully functioning app. I want to call your attention to this drawer widget that I am using here. This is another out-of-the-box widget that's really cool for building navigation in. It comes with all of the swiping and animation that you see when you go to another page. It provides this back button. It just has a bunch of stuff out of the box. I didn't have to do anything for it. So worth pointing that out. And then let me show you what's happening over here in Chrome. So Chrome, this obviously is a wider view. I decided for the wider view, I wanted this list to scroll horizontally. And I have the form showing up horizontally. So a couple little changes that I made on the responsive side, if you will. Now, one thing to note is that all of the stuff that you see here, these are all widgets that are out of the box. I didn't do anything custom. I made some customizations as far as color and, you know, font size and things like that. But all of this scrolling action, this is a list view widget. I didn't have to do any logic to figure out like how to scroll something up or down or left or right. It's super simple to implement, and another big bonus to their pre-made widgets. Okay, so enough with the demo. Let me show you the actual code for this thing. Let me pull this down so I have all the stuff I need. Okay. So let me show you image search results here. I'm going to show you how I did the responsive stuff here first. In Flutter, we have a media query widget, this guy right here. And this helps with developing responsive apps in much the same way CSS media queries do, if we've got any web developers out there. You can get the device size and the orientation and make layout decisions based on it. I commented out how you would get the orientation just for future reference. I'm not using it, but there are comments and things throughout this app to just provide a little bit of direction if you do go and get it later. It'll just provide a little more information that I won't be able to touch on everything today. Okay, so remember how the larger web version on Chrome scrolled horizontally? And actually, I should show you how it's not just that it's scrolling horizontally, it's scrolling horizontally at a certain width. Once we size this sucker down, now we're going to vertical. And now we're back to horizontal. So let me show you how I did that. All right, so I checked the device's width. I'm just declaring it here, defining it here. I'm getting the size.width from the media query. I am setting the direction of scroll. This is something that the list view is going to ask me for. So out of the gate, I'm saying let's default to a vertical axis for my scrolling. But then I want to do a check. And again, we're in the build method here. We're building the UI. So we're making decisions on how we want the UI to look. So I do a quick check and I say, hey, if the device width is greater than or equal to my tablet breakpoint, and this is nothing but a constant that I set up in a file. Oh, of course I lost it, sorry. Then I want the direction of scroll to switch to horizontal. And then here in my list view, which has a direction of scroll, I just pass that in. So now when the size of the screen changes, I get a new width, the widgets rebuild, I get a switch in the direction of scroll. It's really that simple. And I've done a couple other changes in the app. Like I said, the form changes. You can do the sky's the limit with what you can do with the media query. But this is one key point to understanding how you can use one code base to build an app for all kinds of devices, all sizes. Okay, one cool feature I want to show you all is this dev tools. DevTools has a number of things, but I'm going to show you the widget inspector because this is the widget tree that the widget inspector shows. And this is a concept that's important to understand, especially when we get into state management. So widgets exist in a widget tree. Remember when I mentioned that the widgets are nesting, you have child widgets and children widgets that get passed into other widgets. So you end up with this nesting. The tree describes the organization of widgets in the rendering stack. So this screen is the home page of my app, and you can see here's the home page. The scaffold that I'm using, I'm going to skip that. We're going to come back to change notifier provider. We have a column that's showing my image search, my results title, this guy, my search results. And it's cool because you can just collapse and expand. The other cool thing is that you can click on one of these bad boys and it will take you to where this widget is being rendered. And you probably can't see the cursor jumping over here. Let me see if I can do one. There we go. So see, this image is part of my destination card, which is what these blocks are. And it just opened up my destination card code. So pretty cool there. Other thing that's cool, let me move this guy out of the way, is that you can use this little feature here it's called widget mode, to select widgets over here in the UI, like on your simulator. And when I click, it takes me to the widget that I just clicked on in the widget tree, and it will also open up the code in the left panel. So this is VS Code. You can also, DevTools also runs on IntelliJ and Android Studio as well. So just a cool way to explore the app. We're not going to do anything else with that, but I do want to make sure that you understand the widget tree. Okay, we're going to head back over here real quick, because I want to talk about the widget tree some more and get into that state management that's a little more complicated. So we have the parent app here. This is another view of a widget tree. We have the parent app here and our home page with our search related widgets nested below. So our form, our title, and our results. For these three widgets to access the same state, there are a few things that we need to do. And they need to access the same state because the form is triggering the request to get the results that the search results are going to be listening to, and that the title is going to be listening to, because we show that query in the title widget in the text. So we need to lift our state up above the three widgets that need to access it. And I used a package called Provider to help with this. Provider is well known. It's recommended all over the place. You won't have any problem finding documentation on it. And it's the only package that I've used in this sample app. Everything else is Flutter out of the box. So Provider does as the name suggests. It provides data down to consumer widgets. I put the provider widget for our state high enough in the tree so that all the widgets that need it can access it, but no higher. I wrapped the widgets that need access to this data in consumer widgets. Any consumer widget that is a descendant of the provider in the tree can access whatever data the provider is exposing. Basically, the consumer widgets are notified of changes in state by the provider. Let's take a look at some code. All right. I created an image search class to handle all the business logic around doing an image search. So this is the data my provider will expose to my consumers. You'll see this class extends change notifier. Change notifier is a simple class included in the Flutter SDK, which provides change notifications to its listeners. In other words, if something is, or in this case extends, a change notifier, you can subscribe to its changes. It's a form of observable for those who are familiar with that term. I defined the default title, suggested destinations, And whenever there's a change, I'm sorry, and I created a getter and a setter. And whenever there's a change in the setter to the title, I call notify listeners. This does exactly what it sounds like. It says, hey, consumers, have a look. Something's happened. Rebuild if needed. I did the same thing. I have a results array or list in Dart. I've defined a list for the results. I provided a getter for that. And then I have this method, which is going to which is what we'll call when we want to search the images and get back the results. There's some async await happening here because we're waiting for an HTTP request to come back. So for those familiar with asynchronous programming, it's fully supported in Dart and Flutter. When we get the results back, then I hit notify listeners. Again, hey, consumers, our results have changed. Go rebuild if you need to. So now we have this class. It's got the data that we want to provide. We need to get this information high enough up in the widget tree so the consumers have access. So what I did is I went to the home page. These are the 3 widgets that need access to this class. So I wrapped their column in this change notifier provider. This is how we provide the class. You can see that it is returning image search in its create property there. We put it above, again, I can't make this point enough. We put it above the widgets that need the access to it, but no higher than necessary. Change notifier provider is the widget that provides an instance of change notifier to its descendants. If you need to provide more than just image search, which you will in an app, eventually you're going to have a ton of these different domains for different widgets. There is another provider called multi-provider that lets you provide a list of different classes here. For now, we just needed one, so I'm using the change notifier provider. So now we have our provider exposing the data. Let's look at how I set up the listeners. So let's look at the search title. So the search title here has results for Spain. That's the last search I did. And what is changing is this text widget here. That's what's changing. So again, I'm going to wrap the widget that needs the data with a consumer widget. I could put it up here, but again, I want to put it as close to the widget that needs the data as possible. Okay, so I wrapped it with a consumer widget and told it which change notifier I want to subscribe to with this syntax right here. I want to subscribe to image search. The data is provided through the consumer's builder, this guy, the second parameter right here. You can name it whatever you want. I named it image search, and then you can access it in the widget that gets returned. So I am accessing image search's search result title. That is the getter that I used for the title in the image search class. I wrapped my search form and the search results widgets in a similar way with the consumer, just like this. So I encourage you to clone the repo and check it out to see how that was implemented. Now, before we move on, I want to show you what is quite possibly the best part about developing with Flutter. If you're used to working with a compiled language, you're probably familiar with the pain of slow compile and debug cycles. Dart has solved that problem. Right now, we have a Dart virtual machine running with a just-in-time compiler. That's what we're seeing happening over here. That means we can see our changes right away. There's virtually no delay in waiting for the app to compile. And what makes this cooler is that state is maintained. It's not reloading the whole app. It's just reloading widgets that need to get rebuilt based on your changes. So let me show you with a quick example. All right, so we've got our title up here. Let's say I want to change the color. How about orange? Very quickly, less than a second, it changed. You might have a delay on Zoom, but it changes very fast to show the new color. Let's say I want to add a bunch of padding or a bunch of margin to the top. Push it down. Cool. Boom. It's down. Super fast. So, and state is maintained. See, we still have results for Spain listed. I could do another search right now. Let's look for, where do we want to go? Let's go to Ecuador. Did I spell that right? Cool. State's maintained. My change is maintained. Let's make it red just for giggles. Cool. So it's a really fast feedback loop. And once you've worked with stateful hot reload, it's really hard to work with any other framework that doesn't have it. Okay. So there are a couple things. I'm running out of time. I want to make sure there's some time for questions. I'm going to touch on a couple things so you know that they are in the app. There is, and to go check out the code. There is some validation that gets built in to this text form field widget. I didn't have to do anything except tell it what text I wanted to show here and tell it what I wanted to check. In this case, I said, is the form empty? Is the form field empty? Cool, show an error. And it handles all this UI, the turning red, the moving the text, the showing the error text. Lots of really thoughtful widgets and settings like this are provided for you. There's an HTTP request happening in here, obviously, because we are pulling in the images. So check that out. There is some routing going on. So when it comes to routing, Flutter has a navigator widget that manages a stack of routes. Routes are pushed and popped from this stack. And you can see this in the drawer widget. If you go look at the code, obviously. This new route was just pushed onto the stack. When I leave this page, it's getting popped off of the stack. So check that out to see how routing works. There's a couple other gems in there. Definitely go take a look. It'll give you a lot more than what you get with the counter app. And like I said, it's certainly not full featured, but it's enough to get you going on several concepts. Okay, let's get back to our slides here. So testing probably deserves its own talk, but I did want to make sure to tell you that Flutter supports unit, widget, and integration testing. Unit tests are just like unit tests in other languages. They test a single function, method, or class. Widget tests verify that the widget's UI looks and interacts the way you expect it to, similar to component tests and other frameworks. Integration tests verify how pieces of the app work together and are performed on real devices or emulators. You do need a package called driver for integration testing in Flutter. The Flutter documentation has examples and recipes on how to get started for each of these types of tests. And you have everything you need out of the box for unit and widget tests. And like I said, there is a package called Flutter driver for the integration testing. Also worth noting that Flutter does provide an HTML coverage report out of the box. Nothing special needs to be done to get that. Here are a couple tools for you. Dev tools, you saw that earlier. That's what we were using to see that widget inspector in the widget tree. But it does a lot more. There's some tools in there for helping you monitor performance to make sure that things are being built properly. You don't have things constantly rebuilding unexpectedly. There's tons of stuff in there to help. Dartpad.dev. So this is what that first counter app I showed you was in Dartpad. And this is great for playing around with Dart and Flutter without making the commitment of installing it locally on your system. Go take a look. CodePen now supports Flutter, so you can check out all the cool things being done with Flutter there. There's a ton of really cool stuff that's been happening over there. Rive, I want to touch on. Rive is software that you can use to build really cool animations for your Flutter apps. Flutter does come with a bunch of built-in animations and animation widgets, and you can totally go wild in Flutter. But Rive just makes it a bit easier to work with if you're doing really complex animations. Adobe XD has a new Flutter plugin, and they just released it to the public. So if you have a design team that you need to work closely with, this could be great for you. Designers can design in XD and then output Flutter code. It's still early days. I mean, it's like they literally just announced it 2 days ago, I think, that it's ready for the public. So, but it does look promising. So Flutter has a really robust package ecosystem, and pub.dev is kind of is the hub for all of the packages. It highlights trusted developers and community favorites. I just took a quick screenshot of one of them. You can see this is a Flutter favorite. This is a trusted developer because it's got the blue shield. It also shows platform support. So some plugins are only going to be for Android and iOS. Some will work on Android, iOS, and the web. And it's important to know what's supported where. So that's what this little guy is for, and that's pretty critical. And then I wanted to also leave you all with some idea of some of the packages that I've found really helpful or that I think are going to be of most use to people coming into the Flutter ecosystem. Firebase is a mature collection of packages for using the Firebase APIs. We've used them extensively at Reddiyo, and they are solid. AWS just announced Amplify for Flutter. It's in developer preview, but it sounds like that's picking up speed, and that will allow you to use the AWS APIs with your Flutter app. The MLKit package is one for machine learning if you're into that. JSON serializable is a very helpful package. It has a lot of code generation for converting your JSON data into models. It's a bunch of stuff you end up doing manually all the time when you're making HTTP requests and getting them into your models, and this just makes your life a lot easier. Sentry is a package for using logging with the Sentry logging service. Very handy, so you can see what's going on with your app when you've released it out into the wild. SQF-Lite, the one that's shown here, is an SQLite package, and we use it for caching HTTP requests on the phones. It's great. And Google Fonts, you can use Google Fonts in your app. If you use this package, it will fetch the fonts at runtime via an HTTP request, and it will cache them locally for you. You can also include them in your assets folder if you don't want to count on an HTTP request, and then they'll be bundled with your app. So there are tens of thousands of packages. Definitely poke around and see what all you can do with them. And I will leave you with a couple of resources. Flutter.dev is the main place to go. That's where you're going to get all the Flutter documentation. You're going to see how to get started on your local setup. Gallery, there's also tons of like code labs and cookbooks and recipes and things like that there for all sorts of solving all kinds of different problems with Flutter. Gallery.flutter.dev is exactly what it sounds like. It's a gallery of Flutter projects, so you can go be inspired there. And the flutter.dev/community here has a ton of resources. You'll find links to the Flutter Slack, Discord, Reddit, Medium, all kinds of great stuff put on by the community. And it's worth mentioning that the Flutter community is seriously one of the best things about Flutter. I've been a software engineer for about 20 years. Yeah, 20 years now, wow. And I've never come across a community that's so excited about a product before. The willingness to share and help each other is really unmatched in this group of people. And Google has done a lot to nurture it as well. Their Flutter and Dart programmers are very accessible and incredibly helpful and responsive. So I definitely hope to see some of you in the community soon. And then I'm definitely going to have to promote Flutter Denver Meetup again. If you're interested in digging into this framework, come join us. We love geeking out on it. We meet once a month and would love to see some new people. And lastly, this is the link to the Vacation Dream Book app, should you feel so inclined to check out some more code and poke around. And before we close out, I want to point out that any business can benefit from using Flutter. I know this is Denver Startup Week and we're talking about startups, but larger companies can see the value in having one team, maintaining one code base just like us. It saves them time and money, just as well as it saves Reddiyo time and money. Here are a few big names who've jumped on the Flutter train. Like I said, Google is heavily invested. They built Stadia, their cloud gaming service, with Flutter. They've built Google Assistant with Flutter. So it's not going anywhere. It's doing nothing but picking up speed. So that's it. Thank you for sticking around this long. I'll take a few questions with the remaining time. Feel free to reach out on Twitter. My DMs are open. If I don't get around to your question today, I'd be happy to continue the conversation over there or at the next Flutter Denver meetup. Okay, so let's get to a few questions. Can you do continuous integration and delivery with Flutter? Yes. You can. There are a couple of products out there that I know of. CodeMagic is the one I've heard the most about. You can also use Travis and Bitrise. And I think there are a few others, but those are the ones that come to mind immediately. Can you use Flutter in existing native iOS or Android project? Yes. You don't have to go all in at once. You can bring in pieces of Flutter via library or module. And there's some documentation around this, and I'll be happy to find that and share it out on Twitter later. I think they call it add to app, is this feature of being able to plug in pieces of Flutter in an app and kind of gradually choke off the existing native app. Okay. Is there anything like Redux for Flutter? Yes, there's actually a package for Redux, for using Redux with Flutter. There's also one for MobX and RxDart if reactive is your jam. There are a bunch of state management packages to choose from. So whatever, if you are into a common pattern, somebody's probably already created a package for it. Okay. I've got time for one more. What is the performance implications of using something like Flutter as opposed to direct native iOS or Android? As far as I know, there is no implication. You are compiling to native ARM or x64 code. It is native code. So as far as I know, and I certainly haven't noticed any difference, and it's quite performant at 60 frames per second. So it's solid on that front. So that is all we've got time for. I am happy to, like I said, continue the conversation on Twitter. And I just want to say thank you again to everybody who stuck around. And I hope you enjoy the rest of Denver Startup Week.